let's talk a little bit more about methods in this video. We're going to be talking about returning methods. You can make a new project if you want. Entirely up to you. I'm just going to use this old one I've got up here because I got several methods listed here already. Now, there are two ways to interact with a method. If I create a method up here and I don't call it, which is to say put the name down here and run it, it's just going to be ignored. And I can pass things to it, right? So if I run it, I can give it things, which is what I'm doing in some of these here. But a method or function can also give you things back. So I can pass up values, and then it can give me a value back, so I can plug it in here. The one negative about running these functions here is they are separate. That's positive and negative. It's separate from the rest of this code, so if there's a problem, I can usually find where that problem is a little bit easier. It's definitely within this function. But because it's separate, any values that I throw up here are different than the values down here. So if I make a variable, nine, right? And I come down here and I pass, variable to add, for example. Oh, let's just do that. Yeah, we'll just do that. Now, the 9 is going to go up here. We're going to add 10 to it. And it should essentially just print off 19. Oh, oops. I can't say variable num. I'll just call it variable equals. There we go. And you'll see 19 pops up when it was 9,000 before. So this variable popped up here. Now, if I were to print the variable right here, is well, what do you think the value would be? In this case, I'm passing this 9 value up to add. In add, I'm printing and adding 10 to it. Even if I were to come up here and say, number equals number plus 10, and then just print number. So I'm adding 10 to the variable. Well, the variable is 9. It's 19 up in the function, and it's still 9 down here. What happens is I'm passing not the actual variable up here, but a copy of it. There's a couple ways you can pass things. One is passed by reference, which means I'm passing a pointer value. And the other is basically you're passing the number. You're passing a copy of the number, I should say, passed by value. So if I pass the value goes up here, and I just plug that value into here, or I copy it over. The original is still here. It's completely separate than the one that's up here. Even if they were the same name, it doesn't matter. This value is different than this value here. Or the values are the same, but the actual variables are two different things. So when I run to this, I have two variables. One, this one here, and one called number. Even though the value is 9 in both of them, I come up here, I change it. I'm only changing it in this copy that's up here. Once this finishes, we come back here. Well, variable is still 9. I did not change the original. Now, if I passed by reference, or if I used what's called a global variable, which we'll get into later, I can declare a variable way up here at the top, and it's considered a global variable. That means every single function will be able to see it. Every single thing can change it. Now that's both good and bad. The good is, well, everything can change it. I don't have to pass it to every little function that I've written. The downside is everything can change it. Sometimes you don't want everything to be able to have access to something. Smart programmers tend to prefer to keep everything kind of encapsulated in itself, to not allow other people to just willy-nilly change things. So, with that being said, let's talk about when I pass things up, and then this value, or this method, function, gives me something back. Right now, they don't give anything back. They're essentially giving nothing back. So if I say def, we'll just call it gives returns. Let's just call it product. And I'm going to give it a value. We'll just say number 1, comma number 2. Something like that. And all I'm going to do is simply just use the keyword return. And I could have like total equals this, blah, 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 blah. But you don't necessarily have to. And I'm just going to say number 1 times number 2 in this case. Now, same with all the others, I have to call the function product. And in this case, I give it some values, 10, comma 10, that should be 100, right? Now if I run this, you'll note that 100 did not appear. And the reason it did not appear is because when this runs, 10, 10, it's brought up here, dropped, 10 and 10. It's going to return 10 times 10, which is 100. And then that value is going to come right back here. And this phrase here is going to become 100. Well, what am I doing with that 100? I'm not printing it. I'm not saving it. Now if I did this, variable 2 equals that. In this case, variable 2. Now that value is getting stored somewhere. And you'll see the product is 100. So in this case, and I could put this into the print statement here too, in place of variable 2, but the difference is it's not saving anywhere, it's just going to run and print. Typically you're going to want to save the value somewhere and then print it. Then you have that value. If I put it in here, it's going to run every single time that you see a print statement, and it'll be a separate instance of it running. A good example where people go wrong with this is, let's say I have some sort of random number generator that gives me dice rolls for a game or program or something. And I want, me to roll, another player to roll, and I want to compare the rolls. I would want to save those rolls so I can compare them. If I were to print them, you would see the value, but I wouldn't be able to save it. I wouldn't be able to compare the two. And if I did another one, it would basically roll the dice again, essentially. So I only want to roll those dice once in this case, save that value, and then compare the values that have been saved. That's an example of how that would be. Now you can, of course, return anything you want. It could be names, it could be numbers. Def, say give name. And in this case, let's say I don't have to give it anything. Let's just say I want to randomly do a random number generator or something. We'll just fudge that for a second and just say var equals 1 or something. If var equals 1, and actually I don't have to necessarily have the parentheses, I'm just so used to having them that it doesn't really matter, but return Bob, let's say. And elif var equals 2. Return Jamie. If I'm going to capitalize that, I should capitalize that as well. Elif, we'll just go with 2. Else, meaning if it's not 1, 2, if it's any other number, return Jack or something. Alright. Now, let's just say I take that part out. I just say, oh, never mind, I didn't mean to do that. And I run. You'll see the product, and this isn't running, so we'll come down here and we will just say give name. All right, and it should return Bob theoretically. So let's see what happens. Oh wait, I probably should print it. Let's do that. Print. There we go. So I told you before I could print the method as well, or function. Let's see, so it did Bob. Hooray. So we have if, elif. Now if I were to go down to, let's just say 3, there isn't a 3, right? And you see it just says none. Nothing comes back. Now in C++, Java, this would not be allowed. They would actually complain. You have to have a return for every possible outcome. And even in Python, you should have a return for every outcome. In this case, you're going to have an if, elif, else. And the common mistake here is for someone to do if, and then have else at the end somewhere. If you write it just a bunch of ifs, there's a possibility that it will not, return for every single statement. Depending on the rest of the code that you've got written, that could be it could break some things depending on what you're doing. There we go. So you do want to return for every possible outcome. So in this case, if, elif, else, and then I have a return for every one of those instances. With this case, I run it, and it's going to return something every single time. I don't want to get a none or an empty or null or something because it didn't return. Especially when that value is going to be plugged into a variable somewhere and I do some math on it. Really quick and easy way to crash your program. But that's kind of the rough rundown of how returns work, and it can return, like I said, anything. This would be something, I want to pass up some numbers or something, do some math, then I want to get that value back and plug it into something else. That's when you would want to do this. Now, as you can see here, maybe I'm picking a random name for a character I'm making in a game or something. So I have a function here that essentially just, picks and chooses through 100 random names or something and returns that name. And I hit it again, it's going to run, pick a different name every single time using the RNG. That'd be a good example of where this type of method would work. I want to get something back and I want it to actually set something. Now I don't necessarily have to have a return if I had a global variable, just name equals whatever up here. Then I could just say name equals Jane, name equals Bob, and I would set it up here. And that would work without the returns. The downside is all these other functions and things could change things up there too. And that could cause some problems, especially if you have multiple people working on a project. That's essentially how returning methods work and when you would kind of use them.